So this next part of, what are we in, objective 5, I think, is solving a linear equation with decimals. And now this is completely optional. You never have to do this. You can always solve an equation with decimals, but some people don't like them. So this is just showing you a way to get rid of them. So for example, if you had something like 1.2, the largest decimal is a tenths. So if you multiply it by 10, you can get rid of the decimal. If you have two decimal places, that's your hundredths. So if you multiply by 100, you get rid of the decimal. So if you have a decimal place in the thousandths, if you multiply by 1,000, you can get rid of the decimal. So why would we do this? Well, let's look at a question like this one. Okay, what did I do? Well, we started with a question, right, like there. We've got 0.06x plus 0.09 times 15 minus x is equal to 0.07 times 15. Then it says annotate the following. So it just means like what happens between step 1 and step 2. So I would say between step 1 and step 2, we distributed. Distribution. Okay, so I don't have to say exactly what distribution I did, but just notice what the doer did, right? That's what I'm doing when I'm marking your test. I'm like, what did they do? And then we look at, what about steps 2 to 3? What did they do? Well, all of a sudden 0.06x became 6x. 1.35 became 135. What did they do? Well, they multiplied by 100. So they took both sides of the equation and multiplied it by 100, because as long as you multiply every single term by 100, you can do whatever you want. So you would end up with 0.06 times 100 is 6x. 1.35 times 100 is 135. 0.09 times 100 is 9x. And then 1.05 times 100 is 105. And so now I'm left with this beautiful linear equation that doesn't have fractions that I can do without a calculator. Whereas this one up here, I might have needed a calculator. So if I look at this one, what happened next? Well, it looks like they collected like terms. Collect like terms. So you end up with 6x minus 9x is negative 3x. And then from this line to this line, it looks like they got the negative 3x by itself, so they would have subtracted 135 to each side. So you could simply write isolate x term, or if you wanted to, you could say they subtracted 135 from each side. I don't care. And now here to here, they obviously got x by itself, so they divided each side by negative 3, so now they isolated x. Isolate x, or you could say they divided each side by negative 3. So if I was trying to keep it quite generic, you know, I could say even this step, I didn't have to say multiply by 100. I could have said multiply to get rid of the decimals. So if I was looking back at steps to take when solving a linear equations with decimals, what would I do? Well, step number 1, distribute. Step number 2, multiply each term by a factor of 10 to get rid of the decimal. Step number 3, you're always simplifying. So whether you distribute again or whether you collect like terms, and then from there, you're really just trying to isolate x. Now, I just want to take a second here to show you that, you know, this is the way the textbook showed it, but right up here, you could have gotten rid of your decimals here. And some people can see it, some people can't. And if you can, it's awesome if you can. 0.07 times 15. Okay, so if I wanted to, first thing you have to recognize is how many terms are there. So terms are anything that are multiplying together. So this is one term, everything's multiplying together. Here's another term, everything's multiplying together. And same thing here, this is a term, everything's multiplying together. So I could at this point multiply every single term by 100. I don't have to distribute first, especially because I don't really want to do 0.09 times 15 if I don't have a calculator, right? So I'm going to multiply every term by 100. Now, if I do that, what's going to happen next? Well, 100 times 0.06 is 6x. People are generally okay with that one. This one, people are like, well, what do I multiply together? Well, my question to you is, if you have 2 times 3 times 4, if you do 2 times 3, you get 6. You take that answer, you times it by 4. So you're allowed to do 100 times 0.09, which is 9. And then you can multiply that by 15 minus x. You don't multiply both of them by 100, right? You wouldn't do 2 times 3 and 2 times 4 and then multiply the answer together. And then on the right-hand side, I would do that 0.07 times 100 is 7, and then times 15. So you don't have to distribute and then get rid of the decimal. You could get rid of the decimal right off the bat and then distribute and then collect like terms and then isolate x. It's totally up to you. And so if I was going to check this, again, always check into the original equation. So 0.06 times 10 plus 0.09 times 15 minus 10. Does that equal 0.07 times 15? Again, when you're checking, you're simplifying each side. So I'm going to just plug this into my calculator. So 0.06 times 10 plus 0.09 times bracket 15 minus 10 unbracket equals, I get 1.05 on the left, and on the right I've got 0.07 times 15, which is 1.05. Yay! So my solution set is that 10 is the solution to this equation. All right, so here's another one. This one doesn't have a distribution in it, so it becomes a little bit easier. And again, you don't have to get rid of the decimals. Do it with decimals. You're just going to have to use a calculator. Or if you wanted to get rid of the decimal, what factor or what multiple of 10 would you multiply by? Well, you've got a decimal in the thousands, the hundreds, the thousands, and the hundreds. So you'd actually have to multiply by 1,000. Okay, so I'm going to multiply every single term by 1,000. Okay, whatever I do to one, I have to do to the other. And you pick the factor that's going to get rid of all the decimals. So even though the 0.02 doesn't need 1,000, you still do it. And you don't have to show this step. I'm just doing it to be awesome. So I've got 1,000 times 0.008x. And again, 1,000 times 0.25. Right? In this example above, I didn't show multiplying by 100. Right? I just did it. You're allowed to do that. But I like it. So 1,000 times 0.006 is 6x. 1,000 times 0.02 would be 20x. You know when you have those like, I'm afraid of being wrong? 1,000 times 0.02. Whew. Okay, I don't know why. It seems like the weirdest thing to struggle with, but sometimes my multiples of 10 is like my downfall. All right, so plus 30 equals 8x plus 250. Oh yeah, you can just move the decimal place over to the right 3 places. I don't know, all the things. Okay, now I'm going to collect like terms. So 6x minus 20x is minus 14x plus 30 equals 8x plus 250. Now I'm going to put my numbers on one side and my letters on the other. So which one's which? It doesn't really matter actually. So I'm going to subtract 8x to put my x's on the left. So I end up with negative 22x. Having that moment of doubt again. Yep. And then plus 30 equals 250. Then I'm going to subtract 30 from each side. And I get negative 22x is equal to 220. And lastly, to get x by itself, I'm going to divide each side by negative 22. And I end up with x equals negative 10. And again, if I wanted to check it, I would just plug it in for x and make sure that it makes the original, remember nothing that you've messed with, the original equation true. Although it should make every single line true as well. That's the way equations work. Have fun!